In this example, it looks like we have ourselves an indefinite integral, and our integrand is going to be a rational function. So the numerator is a polynomial x cubed plus 2x squared minus 6, and the denominator is a polynomial also x plus 2. The denominator is nice because it's a linear binomial, pretty simple, and that'll come into play here in a second. So how should we go ahead and do this? Well, if you want to, go ahead and pause the video and give it a try real quick. So if you were to use a u substitution outright, maybe you would think that the numerator could be the u, and when you differentiated both sides, you would end up with 3x squared plus 4x. That's not going to cancel with this denominator, though. So a u substitution isn't going to be a great way to go right away. But I do notice that the degree of my numerator is 3 and the degree of my denominator is 1. I could consider actually doing this division, seeing what I have and trying to integrate it from there. So let's go ahead and do that. And we're going to go ahead and use synthetic division since my denominator is simply a linear binomial. And remember, using synthetic division requires our divisor to be in the form x minus k. So this x plus 2 could be rewritten as x minus a negative 2, meaning that my k value here is going to be negative 2. So I'll go ahead and put that outside my synthetic division algorithm here. And remember, synthetic division concerns itself with the constant and the coefficients here. So I'm not going to be concerned with the x's, just the coefficients and the constants. So my x cubed term, or my cubic term, has this leading coefficient of 1. My quadratic term has a coefficient of 2. There's no linear term, so I need to put a 0 as a placeholder. And then this constant is negative 6. And I'll go ahead and put this bar down here. This is my remainder, if I happen to have one. I suspect I probably will. Okay, so this synthetic algorithm, then I'll bring this leading coefficient down, and then it's a series of multiplications and additions on these columns. So negative 2 times 1 is negative 2. When I add, I get 0. The multiplication gives me 0. The addition gives me 0. The multiplication gives me 0. And finally, this addition gives me negative 6 for a remainder. So this is my constant, this is my linear term, this is my quadratic term. And I can also see that my quotient becomes x squared, that's a 0, that's a 0, so minus 6 over the divisor, which was x plus 2. So I could rewrite this entire integrand here as this. Okay, so let's go ahead and do that, because this seems like it's going to be a lot easier to work with. So I'm going to go ahead and say x squared minus 6 over that x plus 2. And all of that, of course, is with respect to x, so we'll keep the dx there. Okay, let's go ahead and move that up. So you could split this up into two separate integrals if you wanted to. So it's the integral of x squared with respect to x minus the integral of 6 over x plus 2 with respect to x. Again, you don't have to do that. If you're comfortable doing this straight from here, that's a pretty quick process. But we'll go ahead and split them up and discuss both of these separately. So the first one here, the integral of just our x squared, that's pretty easy. We're going to add 1 to the power and then divide by that new power. So this will end up being x cubed over 3, or 1/3 x cubed, minus, and then here we need to discuss this integral. Looks like we could do a quick u substitution on this, and we could say that u equals that denominator of x plus 2, which means du just equals dx. And that's pretty nice, actually. So I could rewrite this integral as 6 over u du. Okay, so what's the integral of some constant over u? Well, that's just going to be the natural log. So let's go ahead and now write all this together. So we have 1/3 x cubed minus the natural log, and of course we have the 6 out front, natural log of the absolute value of u plus c. So putting that expression back in for u will give me now this expression right here. So we have 1/3 times x cubed minus 6 times the natural log of the absolute value of x plus 2, and then of course plus our constant. So we can see that that's going to be the integral of this integrand right here, this rational function.